Okay, here we're going to work with a technique called implicit differentiation. And essentially, it's useful because if I wanted to find dy dx, for example, in this problem, I would first have to solve this for y. And sometimes it's difficult. You can see here that would be a challenge to solve this for y. So this enables us to get around that. And we do have to keep in mind that our function dy dx, it will most likely, let's see why that happened there. It will most likely be a function of x and y. So it'll be a little different from solving explicitly first and then finding dy dx. So we'll have to live with that. But let's go ahead and start this. So start off finding the derivatives. And remember, we're going to differentiate everything with respect to x. So essentially, you're doing this. Taking the derivative with respect to x. So this is a good use for that notation that we talked about in the past. All right, so each one of these terms has to be differentiated. Now, this is y here. So you have to view y as a function of x. In other words, you need to use the chain rule. Anytime you see a y, you're going to have to use the chain rule to differentiate it. So chain rule needed on y variables. On terms that contain y, basically, on y variable terms. Okay, so in here, I'm going to treat that as 3y squared times dy dx. That's the chain rule now. Then I want 2y dy dx minus 5 times 1, and then a dy dx minus 2x equals 0. Derivative of -5 with respect to x is 0. So now the key here is in solving this for dy dx. So you'll factor out the dy dx. Sometimes a little algebra is needed. Put that 2x on the right-hand side. And then I have one more step. I'll divide. Okay, so if we don't point the ordered pair that corresponds to a point on the curve, we can calculate the slope then at that point. We have to have an ordered pair to do that, but sometimes that's a reasonable request. Okay, let's do this one here. Just one more example here, a quick one. So sometimes we can solve for y in terms of x, and you can sometimes avoid that. So let's do that here. Let's see, that'll be y squared is equal to x squared minus 1. So y is equal to plus or minus the square root of x squared minus 1. That means we have two derivatives here. When we find dy dx, we're actually going to have a plus or minus now. And now I'll work on this derivative, which remember is as a half, lower the power by 1, and then multiply by the derivative of the inside. So chain rule is necessary on that. This can be simplified to plus or minus x over the square root of x squared minus 1. So we have two portions. This is our derivative, and it's really not a function because of this, plus or minus. Well, this is it, and it's explicit. So you have actually two pieces for this derivative. It's defined that way. Okay.